All right, thanks for coming back, and thanks for doing all the work that you have to do while I'm gone. We're going to talk about rational expressions, and rational expressions. Well, first off, they're expressions, and secondly, they're rational, and by rational, basically what we mean is they're written like a fraction. And rational expressions are any polynomial over another polynomial. So notice a rational expression itself is not a polynomial because you end up with a variable in the denominator. Something like x squared plus 5x minus 7 over, I don't know, x minus 2 or something like that. Itself is not a polynomial, but it is a polynomial divided by another polynomial. And what we're going to talk about is basically how to graph them. And in graphing them, there's kind of a couple of big ideas that you need to keep in mind. And the first one is you can't divide by 0. It's just an undefined operation. It can't be done. So you cannot divide by 0. And the second one, and I'm going to call this 3 big ideas, although these two kind of merge. You got to think about what happens to x. What happens as x gets really big in the positive direction? And what happens as x gets really big in the negative direction? And a mathematician would say that this is like what happens as x approaches infinity. And here they would say what happens as x approaches negative infinity. Negative infinity. So those 3 big ideas, they get us there. And what we're going to do is we're going to use them in order to sketch a graph of some rational expressions. And what we do is we just run it through these ideas, and then we kind of get a frame for it. And we use graphing calculator as well. So let's consider the function f of x is 1 over x. Now that's a rational function. It's a polynomial over a polynomial. And I'm going to graph it. So let me throw in some grid paper here. I should just take a moment. And since I am going to graph it, I'm going to put some axes in here. I'm going to need my x-axis. I'm going to need my y-axis. Great. And so remember, I had these big ideas, and one of them is I cannot divide by 0. And so if I can't divide by 0, what that means is this denominator can't be 0. So basically, the question I want to ask myself is what x values makes it so I am dividing by 0? And in this case, well, it's just 0. It's pretty easy. You put the denominator equal to 0. So x is 0. But what I'm saying is I can't divide by 0. So I've just limited what x can and can't be. X cannot be 0. If I were to plug it in, if I were to go f of 0, when divided by 0, undefined operation. Try that on your calculator. You'll get an arrow. You'll get an error. So what this means for us, that x can't be 0, this is the x-axis, this is the y-axis. X is 0 along the y-axis. If x can't be 0, if we can't have it as an input, we'll never have an output along that spot. So what we're getting is a limitation on our graph. And I'm going to use this, and I'll draw this in here. It's probably hard to see, but it's a dotted red line. And what this line is, I should use the same color to label it. This line is called an asymptote. And I'll get to the definition of an asymptote after I sketch the rest of this graph. So So what we did, we checked if we can't divide by 0. We found one we can't, and what it gave us is a limit. It gave us this kind of vertical limit on the graph. So now I'm going to do the other thing. What happens as x gets big, positively? What happens as x tends towards infinity? And what happens as x tends towards negative infinity? So let's think about that. As x starts getting really big, so like, let's evaluate like f of 10. That would be 1 over 10, 1/10, which is pretty small. Or let x get to 100, right? So 10's here. 100's going to be way out there. It would be 1 over 100, which is even smaller. Or if f was 1,000, 1 over 1,000, which is even smaller. So notice what's happening is, as x is getting bigger, as we're heading towards infinity in this direction, the output values, the y values, are getting smaller and smaller, and they're getting closer and closer to 0. So basically, it's going to get smaller, 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 closer and closer and closer to this x-axis, but it will never touch it. No matter how big x is, like, let's say it's 10 to the 50th, a 1 with 50 behind it. This is 1 over 10 to the 50th, which is a tiny, tiny fraction, but it is not 0. So as x gets bigger, f of x gets smaller, gets closer and closer to 0 from the positive side. And the negative, we could do the same argument. If all these inputs were negative, that would switch all these fractions, make all these negative. So what's happening here is, as x is getting bigger in a negative direction, these values would get closer and closer to 0. Like, negative 1/10, negative 1/100th, negative 1/1000th, closer and closer, but never actually get there. So it looks like we actually have another asymptote, which these tell us, and this is going to be a horizontal asymptote, and it is here. As x gets really big, y gets closer and closer to 0. As x gets really big, y gets closer and closer to 0 from this negative side. So these big points, that's not what I wanted. These big points that I emphasized at the start, these basically give me a frame for where my function is going to fall out. And then what's going to happen is, notice this frame splits it into 4 pieces. There's either going to be something here, something here, something here, or something here. And I can actually kind of just figure out where things are by plotting some points. So let me do that. So let's say x is 1. I plug in 1. I get 1 over, I plug it in, 1 over input is 1, 1. So when x is 1, y is 1. So it goes through that point. When x is 2, it's 1/2. So when x is 2, y is 1/2. And we already kind of have a sense for this. Remember what we said was, as x gets bigger, y gets closer to 0. So when x is 3, plug it in. Notice this is 1/3. About there. So it's getting closer and closer and closer in this direction. And I'll try and draw it reasonably well. But it never touches it. But it gets down there pretty quick. That shouldn't come up like that. That's just my bad drawing. So let's go this way and see what happens. Let's plug in 1/2. So f of 1/2, that would be 1 over 1/2. And notice what I'm doing is I'm dividing by a fraction. So 1 divided by 1/2. When I divide by a fraction, that's the same as multiplying by the reciprocal, by it flipped over. 1 times 2 is 2. So at 1/2, this is 2. Or at 1/3, 1 over 1/3. Again, dividing by a fraction, flip it, it's 3. So if you look at what's happening here, as x is getting closer to 0 from the right-hand side, this is getting bigger and bigger. Like let's say we plugged in 1/100th, right? That's tiny. That's really close to there. It would be 1 over 1/100th, which is 100. So what happens here is it doesn't come back on itself like that. That was poorly drawn. It never actually gets straight up and down, but it gets closer and closer and closer to that as x gets smaller. That's what an asymptote is. An asymptote is a line that a function will tend towards as you get to these extremes values. As x gets really big, as x goes to 0, this function, as x goes to infinity, this function goes to 0. That makes this an asymptote. As x heads towards 0 from the right-hand side, this function heads up towards positive infinity. And notice we have that part of it. There's not going to be anything down here, because if there was, it wouldn't be a function. Vertical line test. And I could do the same thing, plug in points. If I start plugging in negative points, though, right, that just changes the signs of all these. So if I plug in -3, that would give me -1/3. So I'm going to get the same sort of shape, but I'm going to get it down here in quadrant 3. So like -1, 1, -2, 1/2, etc. So going to look something like this without being all shaky. It'll actually be smooth. Here's a graph of this function, and that's what we need to do in this section, is use these pieces to frame out where the potential graph can be, and then to sketch the graph. And what's nice is, we have a graphing calculator. We have a good tool to use for this. And so I don't have a graphing calculator emulator, so I'll just use, from alpha, y equals 1 over x, graph it. And here we go. You can see, like this gives me this nice little crosshairs. If I put it here, I can tell that it's heading towards that vertical asymptote, and it's heading towards that horizontal asymptote. So let's try another one. Let's try another one like this. Let me clean up my mess. So let's try y equals 2 over x plus 1. I'm going to try and graph this, sketch a graph of it. And so we'll run it through those big ideas. The first one is I can't divide by 0. And what this is going to do, this is if there is a spot where I divide by 0, that's going to give me one of my vertical asymptotes. So the way I can check if I'm dividing by 0 is just take that denominator, set it equal to 0, solve it. So subtract 1 from both sides. X is -1. So when x is -1, that makes this 0. So if I can't divide by 0, x cannot be -1. So what that does is that gives me one of my asymptotes. My vertical one. Again, when I say x cannot be -1, this is when x is -1, right? Matched with all these y values where I put this red dotted line. So can't happen there. So that's why that's an asymptote. And I'm going to run it through my other tests, my other big ideas. And that is, what happens as x gets really big positively, and what happens as x gets really big negatively. So let's take a look at this. 2 over x plus 1. So as x gets big positively, this denominator is going to get really big. Like if I go f of 100, this would end up being 2 over, plug it in, 101. Or if I go f of 1,000, this would be 2 over 1,001. So hopefully you can see that as x is getting bigger, this gets really big. So that makes this become 0. Get close to 0. It never actually becomes 0. 2 divided by, basically it becomes 2 divided by big, which is essentially 0, close to 0. So these give me horizontal asymptote. And in this case, just like the last one, it's here. And notice what I have now. I have my frame. And so I know what's going to happen is I'm either going to have something up here or down here, and I'm going to have something in here or over here. So then the question becomes, well, where are they? Where do they end up being? And what I can do is I can plug in points and get it. So like let's look at when x is 0. That'd be 2 over 0 plus 1, which is 2. So when x is 0, the output's 2. When x is 1, that'd be 2 over 1 plus 1. 2 over 2 is 1. So when x is 1, y is 1. So it's looking like, and since I know these are asymptotes, I know it's headed towards those. So I got there quick. It shouldn't wave around on it like that. And I could plug in points to the other one as well, just like I did here. And let's see, -1. So I'll plug in -2, see what happens. 2 over -2 plus 1 is 2 over -1, which is -2. So when x is 2, y is -2. Just a nice little symmetry going on here. Plug in -3. 2 over -3 plus 1 is 2 over -2, which is -1. So when x is -3, this is -1. And you can see it's going to take on this shape. Oh, God, that was horrible. Oh, that's even worse. Oh, my gosh. I'm sorry. Here we go. Boom, boom. And again, notice at these extreme values, it gets really close to that asymptote. It starts to get close to that asymptote. Now, this idea of plugging in the points to get some shape of it, it's fine. It's a good method. You should have a graphing calculator in your hand. So what you can do then instead is sketch a graph of that graphing calculator. Do the work to figure out where the asymptotes are. But then this is going to give you, when you graph it, when you use graphing calculator, it's going to give you some nice shape on it. Notice that I used parentheses around the entire denominator. You're going to need to do that. And if there's something more in the numerator than just 2, you'd have to put parentheses around it as well. So I'm going to graph this. Yep, and notice, here's that -1. Here's that 0. There's my 2 asymptotes right there. That's great. On your graphing calculator, sometimes you'll get really funny odd results. Like if this was your graphing calculator screen, shaped exactly like that, it might like do this, but then it'll go bump like that, and then try and draw the rest of the graph. Here's what's happening. Here's what's happening here. When your graphing calculator graphs points, it actually just like goes along the x-axis and goes, okay, I'm going to compute the value of this point. Like if this is the x-axis here, it goes, okay, here's an x value. I can compute this value. Here's another x value. I can compute this value, and then it connects them. So it actually doesn't do like every single point. It couldn't. It has to have a gap between points, and then it figures, oh, there's some sort of curve between here. Or they're so close together, and that's a highly pixelated screen, that it just looks like a curve. But what it does is it figures out this point, and then it figures out this point, and it doesn't know that nothing's going on between them, so it connects them like that. So this line that will appear on your graphing calculator for vertical asymptote is just a quirk of the machine. It's not showing you where the asymptote is. It's just graphing it wrong. It just happens to look like an asymptote, depending on your settings. So know how to interpret your calculator. All right, here's what I'd like you to do now. I've done a couple of examples. I've given you some tools. Don't divide by 0. That's going to help you find vertical asymptotes. Let x get big positively, let x get big negatively. That gives you horizontal asymptotes. So what I want you to do now is I want you to sketch a graph. And so let's do y equals 3 over x minus 1. Sketch a graph, find the asymptotes, talk to each other, talk about it as a group, and then when you look at the next part, you'll see at least how I would do it. All right, good luck.